All right, so today we're going over the final project for fundamentals of aerodynamics in XFLR5. We are going to be doing the wing analysis for the wings with taper ratio, and we're going to be looking more specifically at the wing with the taper ratio of 0.6 for this example. Okay, so to begin with, click on module and we want to go to XFoil direct analysis. So we get this pop-up, and now, so we're gonna start with the airfoil before we go to the wing, so we could set that up. So we're going to make it NACA foil, which is what we're looking at, and then 2415, 100 panels, which is fine, and we could just leave that as that. Here it appears at the bottom. Now we go to design and refine globally. Just gonna change the number of panels here to 100 to reflect the other one. Okay, and we overwrite that. Okay, so now we go to analysis, and we're gonna do a batch analysis so we could get all the alpha values. We don't gotta repeat it like 15 times. And yeah, so last time what I found out, the default was 3 million Reynolds number as a maximum. I changed it to 4 million so it doesn't crash when you run it. And here it's already pre-done because I've done it before, but we go from -5 to 15 with increments as 1 as the project instructs. And we're going to click analyze. I'm gonna wait till that finishes. It's gonna do all the stuff in the back. Cool. So now we close out of this. And see that. We could see all of those. And okay, now we're gonna actually get to the wing, and we're gonna go wing and plane design, and we're gonna click on plane. Oh, define a new plane. Okay, so now we got this. We just want to look at the actual wing itself. So we're gonna uncheck the elevator and the fin, and now I'm just gonna name this taper ratio equals 0.6. So to make it easier, and we're gonna go to define. All right. So to get an aspect ratio of 10 with a root chord length of 1, so it's going to look funky for a sec, we're going to take the offset off. The chord tip length, the tip chord length is supposed to be 0.6. That's for the calculation. And then the span right there should be, well, you got to calculate it, but I already did it. It's going to be 4. Wait. So it's going to look something like that. Here on the side, we get a wingspan of 8 meters, which aligns with b squared over s. Calculate that. Traces back to 10. Here, aspect ratio 10. So here we have that. It's all good. Last thing before we proceed is that we want to change it to NACA for the tip and the chord so that it updates. And the X panels, we're going to do 19. All that does changes the amount of points it looks at. And all right, we're going to save this. Let me double check that everything is right. Yes. Here's your. All right. So we got that. Named it. We save it. And here's the wing. We can see a geometry. We could play around with it. Here we go. Now we want to go to analysis, and we're going to define an analysis. And here we could change the free stream velocity. So it was 50 in the example, leave it as a fixed speed. Yeah, fixed speed. That's fine. We're gonna check off inertia. We don't need it. And all of this looks fine. We save. And on the right, we're gonna double check for -15, -5 to 15, and change of 1. And now we analyze. So we're right here in the OP point of view, but we're gonna go here, which is what we want. Let's go to 1. So this is how you get, this is CL versus alpha. As you can expect in the small angle of attack, you get the linear linear region, but as you start going off, it's going to be less and less linear. Now, all right. Okay, there we go. My bad. So this is CD versus alpha, coefficient of drag. The last one was coefficient of lift. Here we have it. The next one, let's see if we can find it. Okay, and now here's the coefficient of lift over coefficient of drag versus alpha, angle of attack angle. And this is what we can expect. We're going to press A again. We're going to view all of these. And okay, so now we want to look at we're going to go back to OP point view, which is looking at the span. And I'm just going to change the color of this to just make it green, I guess, or probably orange would be easier. So, okay, so we want to, induce angle of attack here, and the Y. And then for 5, it's for 5 degrees. Here we have the distribution along the wingspan, which is on the x-axis. The y-axis is the induced angle of attack. As we can expect, it's going to be negative on one side because the wing is on the origin, so it spans from negative to positive. The next thing we're going to look at is the variation of the local lift coefficient. So we're going to double click here, local lift, click OK. And there we go, we got the change. Here we go. And lastly, we're going to do the induced coefficient of drag. So induced drag coefficient. Here we go. Here we have it. And that is about all there is for the video today. So yeah, that'll be all for the project.